Will inaugurate the event by lighting the lamp. So I request our CEO, Dr. Anand Deshpande, to please come on stage. Along with that, I would also like to invite Mr. Sunil Sapre, our CFO, and Mr. Atul Khadilkar, who is the CEO and President Operations, to come on stage. I would like to invite on stage Mr. Nimit Tanna from CWC Advisors. And Mr. Pankaj Kapoor from JM Financials. Thank you. And I hand it over to Dr. Anand Deshpande now for the opening speech.
Thank you. Am I audible? First, thanks a lot for being here. We do have a little bit of a challenge on the traffic between Mumbai and Pune. So the way we are going to do this is we are going to extend my speech by 5 to 10 minutes more. And we will run about 15 minutes behind till lunch. And then we will catch up soon after lunch. We still want to have enough time for Q&A at the end, and also have plan to finish the event as scheduled. So we'll adjust a little bit as we get going. With this, let me invite you. Let me start by giving you a very quick overview of the company. Many of the things that I'm going to share in this session are well known to everyone, because many of you have been tracking us for several years. And you have pretty good understanding of some of the business that we are in. But I just want to set a little bit of context in terms of what we are doing, and also set you up for the rest of the day. We found that in many of our conversations before that there were many areas of interest that you all have, which you will see during the day. And at the end, we will come back and answer any specific questions you have about the business, what is happening in the climate, in the industry, and all of those kinds of things. So really look forward to a very exciting and a fun day today. As you would expect, we are going to discuss many forward-looking and things that you have to take with caution, and so these are the disclosures. In this session, which we will go on for the first part of it, so I'm going to start by giving you a quick overview of the company. Spend a little bit of time trying to tell you on our focus around data, digital, and IoT, and how we see that. We found during the last few interactions that blockchain has become an interesting area that everyone wants to know more about. So we thought we would get our blockchain expert, Pandurang, to give you a little bit of an overview of how blockchain is being used beyond cryptocurrencies. And he's got a good session going, so I'm going to give him as much time as I can during the first session for him. And then at the end, I'm going to come back with an overview of various things that we are going to do today. Many of these things are already there on your app that you would have had either downloaded in the past, or today you could have had it. And we'll be able to share some of those things with you as we go along. So as you all know, Persistent has traditionally been focused on product development. And what has changed in the last few years is that it's not just that product companies are building products, but everyone is building products as people have started to become software-driven businesses. And as you see during the rest of my presentation, you will hear more about this. But essentially, when we define product development, the way we define product development is that, and the best way to do it is to compare it with IT services, is in an IT services project, you typically have well-defined requirements and you do trade-off between time and money. But when you build a product, the first thing people decide is when they want to ship the product. Then they decide how much to spend, and you build the best possible product within the time and money. And this is traditionally what product companies have done for many years. Today, enterprises and businesses who are starting to build products or solutions are starting to do it this way, because this is the best way to get things done incrementally and iteratively, and I'll tell you more about what's going on. We have a focus on data, digital and IoT, and you will see more and more of this all through the day. We are now 9,300 plus employees in 17 countries. That has been the big change in the last few years in terms of the number of countries that we are present now. And you all know the financial details, but just last financial year, we ended the year at 2,874 crores, and the last quarter was 761 crores. So these are numbers that you have more details of on our website as well. So as you all know, and as you would observe, that businesses actually do not grow in a linear line. They go through what we find as S curves. So you have a certain business model that helps you get certain momentum. And then if you have to keep changing your business models every so often to ensure that you get the next S. So in the first S, when the business started in 1990, we were predominantly focused on working with companies that were doing products in the database area, and we were doing mainly R&D type work for these kinds of companies. And that helped us grow very solidly but very slowly. So we touched 100 people for the first time in 1999. In 2002, 2003, we decided to really focus ourselves on outsourced product development. In this, we started to work with product companies and build products for them end to end. And that helped us grow very significantly, and we were already 500 people in 2003 and 2,500 by 2008. And this focus of trying to do very precise stuff really helped us in attracting the right talent and also being very effective in terms of what we do. So we did product development, but product development was typically used by ISVs, meaning independent software vendors, who are the ones who bought products. In 2008-9, we found that many of our customers, and when we met a lot of them at the end of the 2008 challenges that we had with the Lehman Brothers and everything else, we found that many of our customers were looking for support, not just in product development, but also in product implementation and services. So we extended our extent, saying that we would provide full service to product companies. Not only will we build the products for them, we will help them deploy the products, and also we will help them with products that are not strategic to them, and that's sort of where the Accelerate business was born. More recently, we have seen that software is driving the world. We are starting to see all businesses starting to believe that it's a software-driven business, to the extent that we had a quote from the CEO of Domino's Pizza, who said that Domino's is a software company. Now, you would expect them to be a pizza company, but they believe that pizza anybody can make. The fact that they have the software capability to deliver the pizza warm and in the right place at the right time, really what differentiates them. If you look at Amazon, which is the biggest retail store, or any of the well-known companies like Airbnb and others, they are all pretty much a software company. Uber is a software company right now. So every business is starting to become a software-driven business, and that has created an opportunity for us where our product development abilities are not just relevant for product companies, but are relevant for every single business that exists around in this world. So what exactly is meant by this software-driven world? What exactly does it mean to run a software-driven business? And to get that in context, I want to share with you 3 mega trends that we see in the market. The first one is that data is really the oil, and that is really driving the digital economy. So if you want to be in the digital economy, your access to data, management of data, and the ability to deal and monetize data has become the key to the success of any company and any business today. And this is an area that we have a lot of experience and expertise in, and you will see this as we discuss most of the stuff we do today. The Internet of Things has started to happen, and Internet of Things is quite different from the Internet of People. And I'd really like you to reflect on this, because when you look at the number of people we have in this world, it would be about 7 billion, and say 5 billion of them may be using Internet of phones at one time or the other. It's only 5 billion. When you look at devices, we're going to see more than 50 billion devices. Internet of people, you have people who will be on the net for a certain period of time. They'll click some mouse buttons, whatever else, but it's limited to the amount of activity that a person can do. When you look at machines and cameras, they are spewing data all the time, continuously 24/7 in large volumes. So the way the Internet of Things is set up is quite different and challenging as compared to the Internet of people. And this change is starting to happen, and in the next couple of years, you will see it's the same kind of changes in business model and opportunities, because the Internet of Things starts to dominate and the infrastructure for Internet of Things starts to happen. With all the data, network, connectivity, devices connected, there is no way no human being can really make sense of this data. And that's sort of where machine learning comes in, and it's starting to become very mainstream. And today you will see a lot of discussion and activities that we are doing on machine learning that you will find interesting. Machine learning is the key to getting data and network to get to respond things on what is really happening. With these three pillars, what we see is when we work with most of these companies, whether it is in data, digital or IoT, these are the 4 I's that we find are very relevant in terms of what's going on in the market. So the first one is relating to immediate and actionable insights. So what has happened is, traditionally people have used business intelligence and dashboards and various other things in the past. Today nobody is really waiting for dashboards and reports anymore. Everyone is looking for instant results and instant intelligence, so that's what we refer to as actionable insights. An example of this that I'm sure you are familiar with is Google Now, or the stuff that you get on your phone. So today you are not, when you're looking to go to Mumbai or otherwise, you are not necessarily looking for reports, going to a website, building out on apps. You actually look up and expect insights to come to your phone directly. So instead of having reports which were usually pull, now you're looking at many more push related activities across the board. We are starting to see this have a huge impact in the way software is built and delivered today, because people are not anymore looking at apps and solutions like that. What you see on Google Now is starting to happen on Amazon Echo or many of the voice integrated devices as well, where you are looking at actionable insights and you expect the device to tell you what it needs to get done today now, rather than tell you a long report of what might be happening elsewhere. These are context sensitive, location sensitive, time sensitive, and very useful. The second part of it is where you see incremental updates as being the key to the success of software and how software is being delivered. One of the best examples of this is Tesla, which is the beautiful car that you see behind me. And Tesla has done a really great thing of trying to be able to update the car as a software platform on a regular basis. Every incremental update of the Tesla actually upgrades the quality of software and provides you better features than the previous version of the software. Now this has got everyone really fascinated, and people are starting to say, what would it mean to sell equipment like washing machine, where I'm going to keep upgrading the software depending on the conditions that you're using, number of people you have in your family, all kinds of things like that. Refrigerators, washing machines, practically everything that we use is starting to get updated on an incremental and iterative basis. This creates a new sets of opportunities for us as a business, and you will see some of the work we do on continuous integration and the work we do with IBM in this context, where people are building things on the fly and keep them incrementally updated. The third I is about integration, and this is a favorite product of mine. I really like this cool product called Lift, which is something you should try out. And this really allows you to bring in things together from disparate partners who don't necessarily collaborate with each other. So by using a simple software like this, people are able to expose the right levels of APIs and bring in data that comes in from many different areas. You will see some of this at work in some of the hackathon examples that you see, where in a short period of time you are able to integrate data across unrelated businesses or partners that don't necessarily collaborate with each other, because they are exposing and sharing data sets through an API layer, which becomes very effective. There's a cute example that they have on their website where you can automatically light the way for the pizza delivery guy to come and deliver the pizza to your house. So this involves integration between the pizza delivery system, which is available today, It involves integration with your lights, where you can connect the Hue lights or other lights to the network so that you can actually set the lights on or off depending on somebody coming into your house. So some very interesting excitement, predominantly because your ability to bring in data together in very interesting ways. If you look at in India right now, there's a lot of activity around the India stack, which is an API level that is starting to happen. And I'm very excited at the opportunity of being able to integrate data from different kinds of sources, including payments and other areas, which is starting to create a new set of opportunities that is highly disruptive. So with all the stuff that is possible with banks, Aadhaar integration, and a whole bunch of infrastructure that is getting created in India, we are looking at some very exciting possibilities of how this ecosystem is going to play along. And finally, nothing like this is possible unless you are able to bring in revenues and make business models happen. So this is an older example of something we had done many years back with Bridgestone tires, where Bridgestone sells tires as a service. So by kilometers run on the tire rather than you buying tires. Now this is very revolutionary from the usage point of view, because if you are a truck fleet which has many trucks and you fly them, let's say, this is used in Europe. So if you look at trucks going from say Spain to Sweden and back, you may have to change tires a few times depending on the weather conditions, and you don't need to carry any extra tires or have local warehouses. You can walk into or drive into the Bridgestone facility, change the tires as appropriate, and keep going. These kinds of business model changes are really where the world is going to move, and that's where the excitement is going to happen. The ability to bring the data at the right place at the right time, the ability to integrate that, intelligently respond to them on an incremental basis, is really what this next generation world is all about. That is what is making businesses software driven. I want to share with you one example of something that we have done to put all of these things into work at our place. So one of the challenges that we have asked our teams internally is to say, can you tell me which project is likely to have a problem next week? So here is an example what happens internally. So we have run about 800 projects across the company concurrently. These are for different kinds of customers across the whole board. Now, as a CEO or a CFO, you are always interested in knowing which project might have problems. Certain things go wrong, people deliveries are slipping, whatever else the reasons may be. Wouldn't it be nice to have this information 1 week in advance of it happening rather than after it has happened? So this is really what we have done. So we have taken data from internal systems. Nobody has to fill in any reports or updates. We look at activities such as people coming in, going out, sentiment analysis of email, looking at what kind of traffic happens on email, what people are saying on email, and then finally putting it all together to be able to alert which projects are likely to have issues next week. And these kinds of things are really becoming the norm in the industry, where people are not looking at past data to give you a static report, but we are looking at active dynamic reports that are giving you actionable insights. And this involves all kinds of things that I described earlier on. So with this, let me say that, sorry. So, we have this strategy now in place for the last couple of years. In the last 2 years, we have seen that whatever we have said to you 2-3 years back still holds good, and the focus really for us is not to invent something new at this time, but to really stay focused on doing what is right and executing well. So the focus for the last year or so has been mainly on these 3 things: is to stay focused, not try to do too many different things, collaborate, and to execute. And you'll see more of this when we talk about during the rest of the day. So we have real focus on the infrastructure side, around data, digital, and IoT. We think that, as I mentioned to you, data is the new oil, and all kinds of things happen in and around data. So ability and capabilities around managing various aspects of data is really the focus of the company, and you will see some of these examples in various projects that we will showcase to you later in the day. IoT again is another way of collecting a large amounts of data, because you now have the ability to have two-way relationships with things, which is really what the Internet of Things is going to do. It allows you to do a lot more than just respond to data and look at static reports. So that's really what we are focusing on. And finally, digital is what I described to you, the 4 eyes of what needs to happen. In terms of vertical areas, and you will see some of this again today, we have been focusing a lot more on financial services and banks who are going through a huge transformation at this time. They are looking at different ways to monetize their assets, and that creates a new set of opportunities. We also have a very good set of partnerships and work that we are doing in the healthcare area that you will see more of as we look at some of the examples from today. And then finally, because of our relationships with various partners in the industrial IoT area, we have been seeing a lot more activity around doing IoT in the industrial area. So with this quick introduction about what we are doing in the overall scheme of things, I just wanted to give you a very quick short highlights of what has been the new things during the year. So in the last few months, we've signed 3 partnerships and acquisitions, which I think are worth mentioning here. So first one I mentioned is in the healthcare area, where we have a partnership with Partners Healthcare. Partners Healthcare is a very well-known group of hospitals in the Boston area. So the 3 most well-known hospitals that they manage are the Mass General, which is Massachusetts General Hospital. The second one is Brigham and Women's Hospital, which is again a very famous hospital in central Boston. And the third is Dana-Farber Cancer Institute. And these guys are all owned part of Harvard University, and they all work together as a consortium across with Harvard University. So what we are doing for them, you will see more of in one of the sessions. But we are working with one of the world's leading cardiologists on looking at how to build systems for CHF. And I'll not go too much into detail here, but the arrangement here is we are using some of the 4 I's that I mentioned to you earlier of how do you innovate business models and activities using actionable insights, access to data, and Internet of Things, and bringing it all together in the medical context. On USAA, which is again the bank for the 4Gs in the US, they have had the best reputation of security systems, where they have built out very nice capabilities on allowing individuals to decide, or the application to decide the nature of security that you're looking at. So as you all know, when you use your mobile devices, sometimes you get PIN codes to look at entry, but that has its trade-offs, because if somebody were to get your PIN, they would get access to it. On the other hand, biometrics and other things, while available, are often inconvenient and not very easy to do. So Neuro has a very nice mix of deciding the kinds of biometric or the kinds of security protection you need depending on the application and the activities you are doing. So if all you are doing is browsing a website, maybe a PIN is enough. But if you are starting to move a lot of money in locations that are suspicious, then maybe you should ask for more information than that. So that's really what the USAA stuff does. And most recently, last quarter, we acquired Parks, which is a Salesforce implementation partner of the DACH region. DACH would mean Deutschland, Austria, and Switzerland. So these are the German-speaking regions in Europe, and this is a software company that we acquired. With this, we got new locations from them in four areas in Europe. So that got us a team in Lausanne, Zurich, Munich, and Hamburg. And with this, now we are in 17 different countries all across the world, where we have development centers and sales presence specifically. Some of the key ones that are worth pointing out, which happened a year back, were Mexico, where we have a center in Guadalajara, and in Israel, where we have a team in Rehovot. We also have a team in Colombo and in Kuala Lumpur that you may be aware of. So we have become a very global company, and as you would expect, the young people in the company have been growing. As a consequence of that, and because of the changes in the way the whole job market has started to happen, we have started a very concerted effort around what we call life at Persistent. And this is something we will showcase to you in the afternoon today in one session. But clearly, in a company like ours, the human capital or the people in the company really make the company. And it is appropriate to not look at people just as what they do at work, but look at people and their lives in a more holistic way and create harmony between life and work. And that's really what this is all about. So how do you get people to be ready so that they are excited about being at work and how that helps them with the rest of their life. So you will see a lot of activities that we are doing around One Persistent, careers at Persistent, and my life at Persistent. Will showcase this to you in the afternoon today. We have continued to contribute our 2% CSR plus more, and this is in all the locations where we are located in India, and we have this thrust areas which are in community development, education and health. Some of the key projects that we did last year, which we are very proud of, is that we set up a solar plant on Pune railway station for about 160 kWp and another 227 kWp at the Hyderabad railway station. These were inaugurated by the previous railway minister, Mr. Suresh Prabhu, just about 3 months back. We have also been focused a lot in Maharashtra with Jal Yukt Shivar Yojana in trying to enhance the trenches for collecting water, which is a huge challenge in this part of the state. When there are no rains, we really have no water. And actually, even if you have rains, the fact that we are not able to collect water means by the end of March, April, the smaller towns have no water for anything. So collecting water is a big part of what we are focused on as part of the foundation. We've got a good set of awards during this year. I don't want to walk through this list, but you will see more of them. I want to finally make one point about this particular event that we did last year, which was extremely exciting. So we hosted a Smart India Hackathon. The Smart India Hackathon last year was held on 1st and 2nd of April 2017. And the event was a grand success. We had more than 36 hours of continuous hacking, coding stuff that was going on. We involved 2,100 colleges across India. At one time when we started, we had 10,000 participants, actually 46,000 participants who participated in the first round, and in the final round, we had about 1,250 participants. 1,250 teams and about 10,000 participants all across India who participated in this in a very exciting way. This thing got picked up by the Prime Minister, and if you hear his speeches, very regularly he mentions about the hackathon as one of his key programs for exciting the youth of the country. So the next hackathon will be held in the first week of March, and we are already geared up and it's been already announced. So you'll see some more activity on it. So the point here is that Persistent, we believe that we are not just a software company, but we are an integral part of the community. And for us to be successful, we need to be not just looking at the day-to-day transactions, but also be part of the country and the community that's going on. So a lot of different things going on here. Now with this, I'm going to take a break here. I'm going to invite Pandurang Kamat, who is the Chief Architect of Innovations at Persistent. He has been working out of the Goa Center for the last several years, and he has been working on blockchain. So what we thought is that we'll give you about a 40-minute overview to all of you on what is happening in blockchain, answer any questions that you might have on this topic, and he will also show you a real demo of what is happening in blockchain. Clearly there is a lot of hype in this area, and let me invite Pandurang on the stage. Are you waiting for the mic?
No, I got it. Thank you.
Okay, so Pandurang, maybe you can educate everyone on what's happening on blockchain.
Sure. Thank you, Anand. Good morning, everyone. So, I'm going to talk about blockchain beyond cryptocurrency. I think all this Bitcoin buzz going around, most of the people in the room are familiar with at least the term. But this is what we're going to quickly cover in this session, right? What is blockchain, the technology that is really powering Bitcoin and all these cryptocurrencies, and what can it do for industries and enterprises beyond the crypto aspects of it? The other thing is, what are some of the business use cases? And then finally, how can enterprises adopt blockchain into their business models? So first, a little glimpse of the hype. It's quite literally at the peak of the hype cycle from Gartner this year. And it's the peak of inflated expectations. And some numbers to put this in context. Bitcoin has crossed, a single Bitcoin has crossed $10,000, I think, 2 or 3 days ago. All of the cryptocurrencies, Bitcoin and beyond, have now a market cap, which itself is a suspect calculation, by the way, because it's not easy to compute market cap of cryptocurrencies. But whatever methods they're using, it's now at about 330 billion. To put it in context, that's bigger than the market cap of Bank of America. This is up almost 1600%. That's not a typo in there, in just 2017. So, and almost $3.6 billion have been raised in what are known as initial coin offerings. So these are essentially capital raising events that happen on top of crypto-based platforms. Now, these numbers are clearly, not necessarily always fundamentals driven, and different people are calling it different things. What we are focused on, very, very, very laser focused on, is decluttering all this hype and figuring out how the underlying technology beneath all of this, which is blockchain, how it can bring value to our enterprise customers. And to get to that, I want to get into what is blockchain really, especially in the enterprise context, right? And the way, one way I like to describe it is that it's an immutable, decentralized, and shared data store. Remember, we are not talking about Bitcoin at this point. It's the chain of blocks and all the stuff that goes beneath it. Essentially, this is what it is described as. The immutable part is that once you put something, once you record something into the blockchain, it cannot be changed. Or if you do try to change it, it will be evident to all the participants. The decentralized part is that no single entity or a group of a subset of entities that are managing this infrastructure can actually collude to bring about any kind of change. You can't bring it down by bringing down a single central point of failure. And the shared data store is that it serves as a single shared source of truth to all the participants that are both running the infrastructure as well as using blockchain for their business case. In addition to this, it's also verifiable by any participant, not just the people that maintain it. You don't have to depend on any one of the parties that maintain it to verify it. You can independently verify it using standard security and crypto things. It's secure. It's secure not just through the standard encryption methods that we use, but it's also, there is a very unique aspect to this decentralized security that I'll get a little more into in the next few slides. And then finally, it's synchronized. When you have a shared source of truth in a decentralized network, it's very important that everybody is on the same page at all times. So the synchronization property is also very critical. So, this is not a comprehensive set of attributes, but this is the core set of attributes that we look at it through in order to particularly solve business, enterprise business cases. So another thing I want to emphasize is that despite all the hype that I talked about, there is some very, very solid, 40, 50 years of computer science that drives blockchain itself. It's got concepts that have been pulled from distributed systems, from cryptography, from networking, from databases, and all of these have come together in a very unique manner to create this brand new technology. None of the individual components are new, but what they put together, created, is actually for the first time in the computer science history. So let's start from the beginning a little bit, just a glimpse of where it all started, right? So in October or November of 2008, a pseudonym called Satoshi Nakamoto posted this paper, a Bitcoin, a peer-to-peer electronic cash system. And with this, and this was on the backdrop of the 2008 financial crisis, so there was a lot of buzz in the crypto community about, how can we build a system that is resilient from manipulation and not being taken down by greed or by a few central entities that run the system. And that's kind of the genesis behind this. And he, I'm using the word he because I think it's a masculine name, but we don't actually know who he is or she is. So he basically brought together this concept of Bitcoin, which was saying instead of having these different banks in different silos which maintain different ledgers, and therefore when you want to move money from one person to another, there are all these intermediaries, there are all these delays, there are all these financial overheads that come in. How about we create a global shared ledger? A global shared ledger that anybody can take part in, that anybody can maintain as well. I mean, you could run a server and a Bitcoin server tomorrow. In this ledger, each page is a block. right? And each block has a bunch of these transactions that are written in it. Now, one of the unique properties of blockchain is that when you create a new page, it gets inextricably linked to all of the previous pages in that chain. And therefore, manipulating a single transaction anywhere in the history of this chain becomes increasingly difficult as the chain grows. So this is one of the unique properties he brought. And then, how do you decide when you are having a global and anonymous network that is running your infrastructure? How do you decide who gets to write, what goes into this ledger? And this is where he brought in another very unique concept called proof of work. This is essentially to simplify things, right? It's a cryptographic puzzle that all of the miners or people that maintain the nodes run, and whoever solves it first gets to write the next block. Now, they don't get to write arbitrary stuff in it because all the individual transactions still get validated, but just they get to broadcast this block. So this is essentially solving the consensus problem, if you will, right? And finally, the obvious question is, what's the incentive? Why should somebody take part in this network? Why should they run this infrastructure? What's in it for them? And that's where the incentive model comes in. So the token, that is the currency, is also at the heart of powering this network. And the incentive is that if you win this proof of work in a given round, you earn some of this token as a reward, and that's a significant reward. And in addition to that, you can charge a small transaction fee for every transaction that you record. Right? So this is essentially the four pillars that brought together blockchain. Now, this was not the first digital cash system, if you will, that was first introduced back in 1983 by David Shawn. What this was is the first ever decentralized cryptocurrency, a cash system or a currency system that was not controlled by any entity, even the ones that are running it, including Satoshi. And clearly, this requires a network effect to work, because for many years, hardly anybody used it. It still chugged along, and now there is a huge network effect that has taken off. So a few years after this, I think 2013, a group of individuals proposed a layered on idea on top of this. What if, instead of just recording data that is immutable, what if we could put code also on it, right? So that computation can be trusted in a decentralized, anonymous manner. And that's where this notion of smart contracts on top of blockchain came about. Now, the term itself, as a philosophical argument, had been proposed back in '96 by another cryptographer called Nick Szabo, but there was no implemented system. But when blockchain came about through Bitcoin, then people decided you can build smart contracts on top of this blockchain. So this is essentially code that runs on a blockchain, and therefore, by definition, becomes immutable. Now think about this. Today, we work with all these services, Googles, Amazons of the world, our banks. We don't know what code they're running. We have a certain terms of service. We don't know if that code is adhering to that service. Now imagine a piece of code that has been audited, certified, and then deployed, and then you know that it has not undergone a single line of change after that has been audited and deployed. Now you don't have to trust the infrastructure, you just have to trust the blockchain protocols from ensuring that. And this code essentially is very simple. It does computation, determinate computation in response to external stimuli, and it can control assets on blockchain, and because it's running on blockchain, it is censorship resistant, just like Bitcoin was. So this was a layered on argument on top of the original cryptocurrency platform. And what it allowed people to do now, because these smart contracts support what are known as Turing complete languages, meaning you can do complex operations like in Java or C++ and so forth, you can now write a lot of your business process code in a system which is having all these properties of blockchain. That was the second innovation. The first release of this happened, I think, in 2014 or 15 timeframe in a platform called Ethereum. And since then, a whole bunch of other platforms have sprung up from there. With this, I want to get into our enterprise focus, right? So all of this stuff I've talked about is what are known as public blockchains. So these are open, anonymous participation. Censorship resistance is a design goal besides decentralized trust. So essentially the innovation that Satoshi introduced, the proof of work model and all of this, these introduce certain token, right, to transact with this platform. You have to pay per play, essentially, for each transaction. And they need a network effect to kind of survive and grow. One of the problems with this is it's also, this decentralized trust is very, very inefficient computationally. And this proof of work is actually, you've heard of all these articles about how much electricity Bitcoin consumes, more than the country of, I forget, Ireland or Iceland, whichever it is. It's a pretty big country, right, on a daily basis. That inefficiency, though, buys you something that didn't exist before. So if there is value to be derived out of that, it will succeed. But the most interesting part that came out of this for enterprises is they said, there are some very interesting properties of immutability and trust that we can adopt from this without having a requirement for all of these other things. So this was the genesis of what are known as private blockchain platforms. Now, these things are essentially consortiums that organizations put together with shared interest and shared business workflows. These have verified identity, admission control. You can't randomly run a node and become a part of these things. So they essentially have the immutable property of blockchain and they use it as a decentralized ledger. So all of us can maintain the same exact source of truth of what's happening in our business workflow. So there is never any dispute. There's a shared single source of truth. And I'm assured that none of us, individually or in small groups, can collude together to alter that truth. So this is a very, very powerful concept. And we'll see in some of the business use cases how this is driving change. So this is what things look like today when you have many different parties exchanging data. There are trusted intermediaries, if you can see here. Then there are auditors and regulators that have to query different sources of truth, cross-checking things. People have their own databases, data stores, and they require this, they have these many versions of truth that requires often reconciliation. This is where we want to move to. A blockchain between these enterprises that is always consistent, a shared source of truth, no intermediary. This, we are arguing, is going to bring in efficiency. It's going to drive down cost in some of these workflows because of both the efficiency part as well as disintermediation, and we'll see some of these cases. So before I dive into the demo, I want to first give a general glimpse of what blockchain can do for businesses. The first thing it can do is cut costs. And that's where, today you have, I was reading an article this morning about a use case where these catastrophe bonds, as they are called, there's apparently a market for this where investors, pay for like an insurance for certain liabilities against certain catastrophic events. If that event doesn't occur, then I get my bond yield. If that event occurs, I lose the bond. And there's an intermediary that maintains this, plays the function of escrow, does underwriting for this and all of that. And this is like they are holding just one of these intermediaries called Euroclear is holding something like $30 trillion worth of these catastrophe bonds. And this is just one segment of this market. Now, if you can imagine what percentage of profits and transactional fees they're taking on this, these costs can be cut because the only purpose they're bringing in this business workflow is that trust, because the other parties don't trust each other. So if you can move that trust to a common infrastructure like blockchain, you don't need this intermediary anymore. The other thing it can do is bring efficiency, and supply chain is a great example of this, right? So if, as anybody who has run a large and complex supply chain knows, that you have these issues of discrepancies of data, either errors, manipulations, fudging of data between different vendors, suppliers, payers, and then you have to spend enormous amount of manpower in sorting these things out. So this is the kind of use case where blockchain can bring dramatic efficiencies. Another thing it can do, because of the immutable nature of it, is it can add a temper evident layer to many of your business cases, right? So this is a powerful property if you're required to maintain audits and have different business partners who are part of that workflow. And because of all of this thing, it will also simplify your compliance. So it dramatically simplifies how much data you have to pull in from different sources to present to whoever you're complying to. And we have a pharma use case I'll talk about briefly. in this. And finally, it can open a whole new slew of new digital business models. Think of peer-to-peer insurance. Think of microfinancing without any central organization facilitating that microfinance. Think of Kickstarter project, but without Kickstarter as a central entity in between. Right? All of these new models, there are people experimenting with peer-to-peer energy trading. You have solar power, you're generating extra electricity. Today you are forced to sell it back through smart meters to your utility provider. In Brooklyn, they did an experiment where you could sell it to your neighbor directly using the utility just as a transmission medium. Right? You can do this with technologies like blockchain, like smart contract. So with that, I want to get into a very short demo to show you a glimpse of what this technology can mean to enterprise in action. And this demo is one for the domain of commercial paper. Some of you might be familiar with it. So this is, commercial paper is a short-term debt instrument that is floated in the market to raise funds, right? And typically its life is between 7 days to a year. And this is how many entities as a sample, and this is a simplified version on the other slide, how many entities are involved, and this 10-step process is a very, very toned down version of it. There are significantly more steps in this, documents that get exchanged physically between these entities, things get signed, notarized and all of this, because they don't trust each other's digital systems, so there are physical systems in play. And this is a fairly lengthy process today. So what we thought is, if you could take this process, and this is a perfect case for modeling on a shared blockchain, you could digitize this whole process and make it, instant transaction. Each party does their workflow instantly. You can compress time from 4 to 5 days to create this paper down to maybe a few hours. So this is an example of that. We have created a blockchain for, the issuer is a corporation called ABC Corporation. Let me try and show you what this looks like. So this is built on a platform called Corda, which is specifically designed for financial use cases in mind. And I'm going to put in a letter of intent and an agreement that we've created onto this. So I've plugged in a bunch of this data already. And I'm going to go ahead and initiate this commercial paper program. So at this point, I would have to send an email or send a courier with some of these documents to the, I think it's the NSDL, to get an ISIN number for this, right? Or go to their portal, upload all of these documents. But at this point, because the NSDL is already on this chain, they can immediately see this newly created, CP418, and they can add an ISIN number to this onto that same common shared truth. So now there's an NSDL server that's recording this, and simultaneously the issuer's servers have also recorded this ISIN. Now one interesting thing I want to show you here is there are all these other parties in between, right? So there's an investor ecosystem from which I'll be picking up an investor to partner with. That investor is not yet seeing this commercial paper. And this data, each of these tabs that you see are actually separate applications, separate enterprises pulling data from their respective data centers, but from a common blockchain. So they are not yet seeing that because they have not yet been given access to that particular digital object. So the confidentiality, inter-organizational confidentiality, is something that is now being built into blockchain as we get into more complex enterprise cases. So with this, I go back to my bank now, IPA, which was involved. As soon as the bank sees that ISIN has been issued, it gets the next action. I can publish the commercial paper accounts onto this. So then the issuer can go back and request a credit rating. Now at this point, one of the credit rating agencies that we modeled, they are still not seeing the commercial paper because I haven't involved which agency I want to go with for this rating, right? So the moment I go and choose, let's say, Credit Reports India, and I request this. After this transaction, now this document becomes, this object becomes visible, and it's instantly replicated on their servers with all of the history. So they can go in and before giving me a rating, they can go in and check whether I've got the letter of intent in place. I can go and open this letter. I can download and see this. I can be assured that this letter has not been modified since it was created and put on this chain. And I can see all of the transactions that happened so far. So this is, this is how it can go on. I can go ahead and go back to my dashboard, issue a issue a credit rating here. And then I can go and choose the investor. At this point, I get the investor involved. And let's say these typically happen offline. I make a deal and then I say, okay, I've chosen RM Investment Group. I'm going to get them involved. And at that point, that group is now able to see this data. So, and I could go on this, but you get the gist. One of the things I wanted to show is all of these transactions that are coming from the blockchain. This is how you can track all the history of this. This transaction happened, credit rating was uploaded at this time by this agency. Their digital signatures are verified. I can go to the next transaction or previous transaction. I can check all this history. And it's just like Anand was saying, right? This is all done through APIs. There is no complex code that you need to build. So if you're an enterprise CIO and thinking about how I can integrate this into my business workflow, it's no different than the standard API-based integration that you're used to. So this is just a flavor of how a complex workflow like this, which requires a lot of reconciliation, a lot of synchronization in the offline world, can be moved to blockchain and be made efficient. There are several other examples. We can quickly look at some of these cross-border payments, and Bitcoin and other cryptocurrencies have kind of already made the case for cross-border payments using that. You can send a Bitcoin to anybody instantly in under anywhere from 10 minutes to an hour. It gets confirmed, and your transaction fee that you pay is much smaller than what you would pay for an international wire transfer. And I've done a bunch of these. Typically, and the best cases can take minimum 24 to 48 hours, and you're beholden to your bank at giving you, whatever rate of exchange that they wish to give you and so forth. So there's an argument and there's a strong case that is already being made for cross-border payments to be streamlined using blockchain. Know your customer, right? And this is about financial institutions onboarding new customers, and particularly corporate customers. So one of the numbers I read is that banks in the US spend anywhere from 20 million to 300 million, depending on the size, annually on corporate KYC onboarding. And a lot of these processes and the vetting that they do has already been done by somebody to the extent that they want. They can pull credit history. They can do that only from certain agencies. What if you had a chain that allowed the customer to permission to share their KYC that was done with other agencies in an auditable manner with each bank? So this is one of the use cases that a lot of corporate banking groups are trying out right now. Even in India, there was an announcement about this recently. Another thing that we worked with a customer of ours is interbank netting and settlement. So typically when banks do forex trading, they require a trusted intermediary to do functions like escrow, functions like actually totaling up who owes what to how much, because they don't trust each other's system. So there is an intermediary that actually is a cost center in between these banks. And there are also delays because that intermediary does settlement at fixed times. Banks have to wait for the universal settlement for their currency pair rather than if just between the two of them. So these kind of efficiencies, we are helping one of our customers move to blockchain and change that. Another thing I wrote here on mortgage and provenance tracking. This is something we modeled for one of our customers in loan and mortgage automation. Their problem was that two problems actually. One problem was they had an intermediary just to offer trust, even though they have been in business for decades, even though they have a very good business rating. They have 3,000 plus customers, institutional customers. They still needed to put all the mortgage documents in a third-party data vault so that they could prove to their customers that they haven't tampered with those, as they age. And the second problem was when you take a mortgage and sell it in the secondary market, it goes through many, many hands over the years. And today, many of these documents are physical documents that actually don't move from one agency to another. And as an interesting aftermath of the 2008 crisis was when banks tried to foreclose on homes who were not paying, some of the lawyers asked them, can you produce the original documents? And they didn't have those because they were like the sixth investor down that chain. So this is a real problem of provenance and ownership tracking of these mortgage objects, even though they're digital objects, across many hands. So this is a case that was very ripe for blockchain. Trade finance, again, a similar pattern. If you have an importer, exporter, you have banks on both sides, you have customs, And today, documents are FedExed when the ship sails for you to the bank that has the line of credit, and that's when you get paid, when they get the physical documents in their hands. So this kind of cases, again, the theme is similar. When you have different organizations that exchange a lot of data, documents, and information across trust boundaries, and if you have a bottleneck, then blockchain is there to help. Another sector I want to touch upon quickly is the government, right? And here there are plenty of use cases, but they essentially carry the theme of accountability and transparency from the government side. And land records is a great example. Several different government agencies involved, from the registrar to the revenue agencies, the town and country planning, panchayats, municipalities, you name it, right? NOC from green tribunals and all of these. Now these agencies have to all interact around the same object, if you will, that piece of land or on one part of it. And the other big problem in land records is that the insider fraud, right? We all are aware of the realities in many of these countries on how things change from within. So if you had a public blockchain which was publicly verifiable, that would mitigate a lot of this insider fraud. You can't tamper with something without everybody knowing who did what. You cannot fudge the record like you could in a traditional database. So this is a great example to move to blockchain. Another thing is upholding service guarantees. So as India particularly moves to digital interaction with the government, you're still uploading things that are controlled into a database that is controlled by the government. So if they say that you filed a wrong document or you never filed a document, they can still go ahead and change things in the back. If the government wants to be truly transparent and accountable, they can actually add a blockchain layer that attests to every interaction that has taken place and what documents were put where and so forth. This can dramatically change the way we interact with government. And finally, interstate and interagency settlements, right? So in certain countries, these are being centralized. Even in India, with GST and all, a lot of this tax reconciliation is centralized. But there are still many countries where this kind of settlements take time, and there is reconciliation which is at the end of the month or quarter. But with a state level and center level blockchains, you can have this, there's no need for a reconciliation because the transactions are instantly visible to all parties. So they are always at the same, same page, if you will. And in healthcare, there are some very exciting use cases we're looking at. One is patient-centric healthcare and health records. So today the health records are managed by different agencies. Each hospital has their own silos. And the patient has very little control on what happens to that data. So if you create a patient-centric ecosystem, which where I manage the data and I decide who to share it with, whether it's for clinical research or whether it's for just getting a second opinion, you can do that using a smart contract and blockchain, a public blockchain, if you will. A very interesting thing, I talked about supply chain a little while ago. Very apt example in healthcare domain is pharma track and trace. Right? And this is a mandate for pharma companies across multiple countries that they operate in. So in Indian, a pharma company, for example, has to comply with our DGFA or something it's called, agency here, and as well as every country that they export to or where the parent company is located. So today, and I was talking to an executive after I wrote an article on this, and they actually sympathize with this problem because they are exchanging Excels with their vendors, with their suppliers, as they track the individual ingredients as well as the finished product across different parties in their entire life cycle, right? So compliance becomes a chore with this. So if you had a blockchain, again, that every one of these parties wrote and read from, then you have instant real-time data available to meet your compliance goals both internally as well as to external countries. And finally, we had a video going earlier about clinical trials, right? So there's a problem in the clinical trial market. If you see, the industry-sponsored trials are 4 times likely to report positive results than independent trials. That's clearly because certain results never get reported, right? The negative results particularly. Then there is this whole question around is consent really being taken? Is it being validated by anybody and so forth? So these are some of the cases which a regulator can move to blockchain and say that your entire life cycle of the clinical trial, each event that you're supposed to take care of will be logged on the chain when it happens. So if you bring me a result for a clinical trial and if you haven't recorded the patient consent 18 months ago, then that clinical trial is not valid. And if you did start a clinical trial 18 months ago and it had a negative result, well, you're now forced to report it. So I think a lot of this transparency and accountability can be brought in the clinical trial space. And that was just one example I gave there. And so this was a non-exhaustive list of domains and verticals where we think blockchain has implications. A lot of this, what you saw here, is driven by the customer conversations that we're having. Now the question is that every enterprise should ask themselves, do I really need blockchain? Right? Because it's not a most efficient data structure or technology to use if you don't need it. If you can do well with a centralized database, if you don't have a trusted intermediary that is adding a problem right now, if you don't have a requirement for a single source of truth, if you don't have multiple writers into this common data, right? If you don't have a business network, I mean, it's an intranet issue where everything is controlled anyway within a single trust boundary, you don't need a blockchain. If you don't have auditability requirements, maybe you don't need a blockchain. So these are hard questions, and again, a non-exhaustive list of questions that we typically work with our customers to figure out if they really need blockchain or they can just do well with the centralized system. Because with all the hype going on, everybody is trying to get onto the bandwagon, and I think it's important to cut through some of that. So here's a typical model of leveraging blockchain. You have to find a natively digital process. Don't try to force always a physical process as the first candidate to onboard on blockchain. Build a proof of value prototype. Get the buy-in for that if the prototype succeeds individually by modeling your other partners, then do a controlled pilot with the partners. And the pilot will invariably bring out problems that you haven't anticipated, so you have to review and calibrate that. Only then you can think about scaling and deploying this. So this is a kind of step-by-step process that seems to work well. And just to close out on, here's a little bit of what the community is focusing on. So blockchain, while there is a lot of promise, we are still at a stage where DARPA was in the initial stages of the internet. There are a lot of performance issues that need to be worked out. There is a lot of scaling issues, the data scaling issues. If you have a data store that always grows, you can imagine that you're going to run into a data management problem fairly shortly, right? So there's community that's working on scaling issues. Privacy is a big problem. I showed you an example of how the community is addressing it, because the first blockchain that came out, everything was visible to everyone. That was the goal, ultimate transparency. But clearly, financial institutions, regulated industries have a different requirement. If two banks are transacting, they don't want the third bank to even have an encrypted copy of that transaction, because they say that 30 years from now, when that encryption is broken, they'll know all our secrets. Legitimate concern, right? Besides the regulatory concerns. So, this is an area that the entire community is focused on. A more efficient consensus model. So you can have faster transactions, you can take out some of the inefficiency of agreeing on things. And finally, inter-blockchain transactions. This is, if you have different chains and they all do different things, how do I move from one to another? How do I take my data and systems and transact on another chain? So this is a very important area that mostly the public blockchain community is focused on. From the enterprise perspective, these are some of the challenges that need to be overcome. The first thing is, as you saw, the recurring theme is you need a consortium, right? You can't just go out and do a blockchain project. You can do a pilot yourself, but you can't have a successful ROI if you are the only one doing this. So this consortium building requires some offline kind of things that are non-technical, for people with shared interests have to come together. The other thing is operational costs. So when you take out an intermediary, you have to run the blockchain to manage their role. So this operational cost has to be weighed against the ROI you're getting out of it. So this modeling of this trade-off is going to evolve over the next couple of years. And finally, regulatory support and interoperability. So regulatory support is very much something that is essential in the industries that are regulated, and most regulators across verticals are actually taking an active look at blockchain as a way to make their job easier and as a way of making getting more accurate information. And interoperability is that if you are a CIO, you don't want to run a separate blockchain on a different platform for your supply chain and a separate chain for your invoicing and so forth, separate chain for tracking your suppliers, right? So you want interoperability standards between these chains. So this is going to be one of the big challenges of these platforms in the coming years. So to summarize all of this, right, here's the takeaway. Blockchain basically brings decentralized trust and immutable single source of truth. If you don't need it, don't use blockchain. Go with your standard application. The value that it brings hinges on network effect. The larger the network, the bigger the value. And for enterprises particularly, confidentiality, interoperability, and performance are going to be key. And finally, the path that I talked about, going from how do you dip your toes and get into this. So this is these are something we wanted you to walk away with. And I want to leave you with this quote from Naval Ravikant, who's a well-known investor and entrepreneur. So he's talked quite a bit about Bitcoin and blockchain and the crypto world in the future. So, and this quote is particularly in the context of consumers and consumer applications, but also valid for enterprises. So he thinks that long run, we are all moving towards these decentralized systems. And some of the data breaches that have been occurring in the last few years, some of the breach of trust that has been occurring with institutions in the last few years, has kind of accentuated this argument that with the technology now being there, maybe we have begun the journey, and it's going to be a journey at least for the next 5-6 years before things get as stable and robust as the mainframes are in banking and so forth. But the journey has definitely begun. It's a very exciting time to be a part of this. So that's it from my side, and I'd be happy to take questions both here as well as outside later. So. Any questions? All right. Yes. Yeah.
Done a rough working of the cost which would be involved in this?
So in this particular model, we haven't, because this is a model that we have built, not an actual pilot that we are doing. But the costs have not been worked out, but at least the banking example, one of the banking examples I gave. So the customer itself has actually gone out and brought that consortium together. If you see the SBI announcement recently, it's again the SBI that went out and played a key role in bringing all the other banks together with shared interest, articulating that value proposition. So what we are doing is helping them with the right tools in making those decisions, what is going to be the ROI. But we have to understand more of the domain and the cost in those transactions to model it effectively. But it's eventually going to be driven by them, yes.
Are you seeing anywhere other than cryptocurrencies these things already in use?
There have been pilots, but not a full-fledged use. I'm trying to think one quick thing. So the energy example that I gave, right, was actually debuted in Brooklyn, and it's been running fairly successfully. One of the challenges is that this technology is so new that even the code that we write, most of the time when we write code using traditional language, we have a slew of tools that let us check for correctness, that let us check for security flaws. And if you've been hearing about, if you're tracking this stuff, you've heard of all these high-profile hacks that have happened. So writing Turing-complete language programs on distributed systems is hard. Computer scientists knew this, distributed system scientists knew this, but cryptographers are finding out the hard way now. Right? So these tools have to evolve before people take these out and put them on critical enterprise systems. But every industry that we are talking with is experimenting with this today as these tools mature.
The other cryptocurrencies have been hacked, but Bitcoin has not been hacked till yet. So what is the difference between?
So I don't want to get too much into cryptocurrency, but let me answer it this way. So a majority of those cryptocurrencies are actually frivolous. Right? So there are very, very few cryptocurrencies that are actually solid based on science. Bitcoin is one of them. And then all these ICOs that have come up layered on top of Ethereum, which was a token currency. I would say 95-97% of those ICOs are either not very required or are sometimes completely scams. So right now there is a lot of foam and froth that is in this industry. So, and nothing moves up 1600% in 9 months on fundamentals, right? So, that's what I'll leave you with. Yeah.
Thank you. I mean, really, it was useful that this could be useful in so many other ways.
Thank you.
For the knowledge.
Yeah.
The business process, how long it will take for the industry to mature in the business process and technology, building tools and platform to get into some stage of maturity where you see NYSE or NASDAQ or NSE playing on this blockchain? So
each one of those agencies that you name, for example, and many others are already experimenting with this technology today. Because the T+2 settlement and all of this, how can we shrink it, make it instantaneous if you're already having digital systems in place, right? In terms of the maturity, my best guess is for you to go for the kind of reliability the financial systems need, it is 2+ years out in order to move your core systems onto this. Because there's a whole slew of things that need to go in place. The stuff I talked about and that the community is working on the left-hand side, that needs at least another 12, 18 months, or if not slightly more. It's not 5 or 10 years out, but it's not here today. But every one of these platforms is in a stage where you can experiment, you can do your design, architecture, modeling, and you can test it out in the field. You can do a controlled pilot, you can take single workflow, and that's what you're reading in the papers, right? Walmart did a end-to-end supply chain from China to their stores down to the consumer's hand. On blockchain. So these pilots are happening today.
But it requires a lot of changes to be made at the server level and at the storage level. Will it be different altogether from what it is today?
Yes, in certain systems, it will be very different. So if you're just looking to add a temper evidence layer to your systems, then it's a minimal infraction. You just have an API call just to check if things are okay. But like the NSE or example, that is going to require a fundamental change in the way you model the workflow. The way that digital object, which is the ownership, equities ownership in something or bond ownership, the way that gets looked at in their digital system, the way you split it up, the way you share control of it, all of that needs to be remodeled. And that's where that's going to take its own time.
Redressal system can become quicker and smoother because of the distributed nature of the system and also the inextricable linkages of documents, commitment, trust. So it makes life easier.
The redressal system, the biggest part is why it will become easier, besides all those things, is that you don't have differences of opinion largely. Because everybody is looking at the same data. It's not that I'm looking at my copy of the data in my database and you're looking at it in your database. So you have a redressal or a difference when you're looking at two different systems. If both of us are pulling data from the same system, we don't have a difference of opinion. So that significantly changes the way we do.
Trust maturity curve will take time to develop?
Yes, trust maturity curve will take time because one of the things I talked about, regulatory hurdles, right? So think about this today, even if I have a data center for European consumers, I can't put some of that data outside Europe. Now I'm talking about having a blockchain of between customs of two different countries where a copy of certain transaction will be stored in somebody else's server in a different geography. How do you iron that out? So regulatory frameworks have to evolve for some of this to also happen. That's
example of a largest implementation of this blockchain application in any bank or any institutions you have come across?
Largest production implementation, Bitcoin is the largest one, and Ethereum. These are open-ended systems. But in banks, banks have done, again, pilots, right? Cross-border pilots of trading and settlement. I think the largest one of the customers that I talked about we are working with, they are going to announce something next year. And that probably will be one of the big ones.
Yeah. Uh, you mentioned in your presentation that bitcoins have been accepted as currency for international payment settlements. Is that a reality? And does any Indian bank accept Indian rupees and the customer then gets X amount of bitcoins to settle and vice versa?
Okay, so let me answer that in this way. So Bitcoin has been used extensively in the last 8-9 years to move Bitcoins from one country to another. They have not moved fiat currency from one country to another. And Bitcoin is accepted as a legitimate transaction medium in several different countries. In fact, Japan recently recognized it as a currency. In US, it is not recognized as a currency, but there are businesses that accept payment in lieu of services or goods with Bitcoin. So you have been able to transfer that value. A lot of Venezuela and